So, Hi everyone. In this video, I'll explain how I identify the local administrative units in Nepal with the most youth skewed absent population at departure. I'll cover the dataset, my algorithm strategy, a streaming top key approach using a binary mean heap, the full complexity analysis, and a brief proof of correctness, then show the results. So, the data set I obtained was from the Census Nepal, the official website of the government of Nepal. The data set is the Anabachi absent population by age at departure. It's in the .csv format. Each record is a local unit with counts by age bands. I restrict to sex equals to total and duration equals to total. Drop aggregate national rows such as Nepal and skip any rows with non-positive totals. The youth share I use is uh, the logic behind it is 15 minus 24 plus 25 minus 34 divided by row total. Our goal is for a given k, return the top k units by youth share with deterministic tiebreakers. So that is number one, higher total. Then number two, lexicographic by province, district, or a unit in a unit, right? So this is youth share formula and filters. This is a classic top k selection problem. We usually don't need a full ranking of thousand of rows. We just want the most use skewed areas designing for top K. Let us be faster and more memory efficient than sorting everything, right? So why did I choose candidate or algorithm B? So um, I implemented and compared two exact algorithms, like both of these algorithms, both algorithm A, the full comparison sort, and the algorithm B, where the algorithm A, which is also full comparison sort, compute a table of every share, total, province, district, and GPA for every row sort descending by the ranking rule, and take the first K, whereas an algorithm B. Um, it just stream rows, push each candidate into a mean heap keyed by the same ranking. If the heap grows beyond k, pop the minimum, which is the worst among the current top k. In the end, the heap holds exactly the k as the best. The results are very similar. Both the algorithms produce identical results, but the reason why I choose the algorithm B over algorithm A is the speed and the memory is like when like the K is smaller than N is like far better efficiently handled on algorithm B, right? So this is the like just a general example of how the algorithms will work, the pseudocode of it. So let's say let the n be the number of filtered rows and k the requested top list, right? Algorithm, what does the algorithm A does in this scenario is that it sorts the n items is like O and log n time is O and space, right? Where algorithm B is also the each heap is pushed or popped is on O log k, I believe. We process and rows once, so total time is O n log k, and space is O k, right? When k is smaller than n, log k is smaller than log n, obviously. So b is really much faster and use like far less memory. When k is equals to n, or you need the entire ranking, a is generally like also acceptable. But when k is like really smaller than n, then the algorithm b is far more efficient and faster on. It's also good for the memory. So it is the reason why I choose the algorithm b, right? So um, what is the mean heap? Uh, let's say how does it work? It works, right? So how does it work? Is mean heap maintains the smallest element at the root. For top k by a descending ranking, we keep a size k mean heap, so the root is the worst among the current top k. When a new candidate arrives, it just pushes into onto the top heap, and if the heap size exceeds k, pop the minimum that discards the worst among the k plus one candidates, preserving the best k. Right. So yeah, this is a pseudocode, the general algorithm I have produced. I'm going to open it. It will run. So it just push pop. It. The procedure of forking is like this, right? So here is the general pseudocode. Obviously, as I have said, we compute the youth share for each row after filtering, pushing the candidate into the heap. Then, if size is greater than k, then pop the minimum at the end, pop everything, and reverse for preservation. Uh, the correctness of the algorithm, which I have yet to discuss, is correctness rests on a simple invariant. Invariant. After processing the first I rows, the heap contains exactly the top key among those I rows. For I, if the I is equals to or less than k, every item is in heap, right? The maintenance also, like if the new item, let's say k plus 1, th or later, we insert it making uh, k plus 1, then remove the minimum, which is by definition the worst among the k plus 1. So the remaining k are the best. After n rows, the heap holds the global, or I should say, overall the global top k. This matches the ordering defined by the key. So, what are the results, or what does the result say? This is like the top 10 youth skewed local units with, given uh, sex equals to sex and duration. For example, uh, Tanja Court, Gaupalika, that is on our local unit, which is located on Humla in Karnali, has a youth share of 92.31%, where 24 of 26 were ages between 15 to 34. We also see Bagmati Gaupalika here. Bagmati Gaupalika here, uh, where 91.83% and Mahabharat Gaupalika also in Kavrepalan Chowk at 91.44%. These highlight areas where absent population at departure is concentrated among youth, which can inform targeted economic or social policy discussion. Right. So you may think like if the both algorithm is acceptable, then what is the condition of it? As I said earlier, the B is overall like streaming mean heap when K is lesser than N, or when memory is tight. Like that is the best case scenario for the algorithm B. Also, that is the reason why I chose it. Or when you want online results as you read the file. But when you need the entire ranking, or when K is equals to N, then like you can use the algorithm A2. But since our data set contain the K that is lesser than N, I choose the streaming mean heap approach. So that I would say I feel the task as a top key selection, implemented two exact algorithms and preferred another for its uh, analog key time. You know. So these are my like Python code for implementing both algorithms. And this is the result of my the algorithm that is chosen. And let's say, I only choose 30 for now, or I could say let's say I choose 7. um, then I run it, upload my file. Confirm what. Stay on please. Okay, I'm for screening. You know, I only have chosen 7 for our test run demo. So you can see, this algorithm produces youth share, youth, and total of it. So that was my overall report.